Now with the second internal paper solution. Myself ASHISH VERMA. I am a second year MTech-IT student and this task is given by Shaligram sir. Question number 1. Write algorithm for Newton forward difference interpolation. So the algorithm starts from step number 1, which is start, second input, number of data in points n, array of values x0, x1, dash dash xn minus 1, corresponding functions value y0, y1, dash dash yn minus 1, value of x at which interpolation is to be calculated xp. Construct the forward difference table for I is equals to 1 to n minus 1, for j is equals to 0 to n minus 1 minus 1. Compute value of h is equals to x1 minus x0. Compute value of p xp minus x0 by h. Initialize interpolated value yp is equals to y0. Compute Newton forward interpolation. Let term is equals to 1, fact is equals to 1, term is equals to term into p minus I plus 1, fact is equals to fact into I. Yp is equals to yp plus term into delta to the power I y0 divided by fact. Output interpolated value yp. Ninth step is AND. Question number 2. Write Python code for Newton divided difference interpolation formula. As you can see on the screen, this is the given code which you can read, which tells us about the Newton divided difference interpolation formula with the outputs. Now question number 3. Prove that sum of Lagrange coefficient is 1. Given Lagrange interpolating polynomial Lx is equals to summation of I is equals to 0 to n, where yi into Lix, where Lixi is equals to pi x minus xj divided by xi minus xj. To prove, the following equation is given for any x. Proof, let yi is equals to 1 for all I. Then L of x is equals to summation of I0 and 1 into Lix is equals to summation of I is equals to 0 and Li of x. So L of x is equals to 1. Hence the sum of Lagrange's coefficient is always 1. Now we move ahead with our question number 4. Obtain Simpson's 3/8 rule from general quadrature formula. Step 1. What is general quadrature formula? We start with general Newton quadrature formula for approximating an integral. As you can see on the screen, this is the following equation for the Newton Cotes formula, where x0, x1, dash dash xn are equally spaced points on AB, and wi are the weights derived by integrating Lagrange interpolation polynomials. Step 2. Choose n is equals to 3. Divide interval AB3 into 3 equal parts so that 4 points are used. H is equals to b minus a by 3. The points are x0 equals to a1, x1 is equals to a plus h, x2 is equals to a plus 2h, x3 equals to a plus 3h is equals to b. Construct the Lagrange interpolation polynomial p3x. We fit a cubic interpolating polynomial using these 4 points, where each Lx is the Lagrange basis polynomial. The following given equation is the integrals of Lagrange basis polynomials given with the weights. In step 4, use non-Newton Cotes weights for 4 points, in which n is equals to 3. For Simpson's 3/8 rule, the weights wi are w0 is equals to w3, which is also equals to 3h by 8. So we can say that w1 is equals to w2, which is equals to 9h by 8. So the following integral is the final result, which is Simpson's 3/8 rule. Now with the last question, question number 5, obtain Simpson's rule from Newton Cotes formula. Simpson's rule, typically 1/3 rule, approximates integration of x0, x2, f of x dx using 3 points. N is equals to 2 over 2 subintervals. First, the setup. Points x0, x1, x2 with h. x2 minus x0 by 2. So x1 is equals to x0 plus h. x2 is equals to x0 plus 2h. Let fi is equals to f of xi. A Newton-Cotes approach. Fit a quadratic polynomial through x0, f0, x1, f1, x2, f2. These are the 3 given points. Substitute t is equals to x minus x0 by h. So x is equals to x0 plus th, where in which dx is equals to h of dt. Limits x0 tends to x2 becomes t 0 tends to 2. Lagrange basis of the points in t 0, 1, 2, L1, L2, L3 are the given points. By integrating them, we get the final formula, which is also known as Simpson's 1 by 3 rule. Thank you for watching this video.